Guidelines for causation. In 1965, Sir Austin Bradford Hill described 9 guidelines for determining causation from scientific evidence. It is worth noting that while one of the guidelines deals with strength of association, or what we might recognize as effect size, none of the criteria deal with significance testing or p-values. Explicitly, Hill called for examining the quality of the relationship between exposure and outcome, the logical features of how the evidence suggests they interact, and how that fits with prior knowledge of the same or similar subject matter. This sort of prescription is well suited to the small N environment of space medicine. Modern causal inference theory, assumptions. Similar to Hill's work, modern causal inference methods may also be of great use in space health research. These methods have sought to mathematically formalize causation in order to make valid use of observational data for causal estimation and to avoid introducing biases in analyzing such data. Perhaps more important than the methods of analysis that this framework has promoted is the understanding of the assumptions necessary to make causal statements from non-randomized data. Merely understanding the assumptions of positivity, consistency, and conditional exchangeability, and what happens when one violates them, can be of tremendous help when trying to draw inferences based on limited data. Directed acyclic graphs. A common tool used in modern causal inference is a special type of network graph known as the directed acyclic graph, DAG. These are network maps that reflect causal relationships. DAGs are drawn according to some simple rules, but making and using these diagrams can be quite useful for clarifying thinking and formulating testable hypotheses. If we factorize a joint probability distribution over a DAG, we create a Bayesian network, a powerful tool of probabilistic inference. If we decompose a correlation or covariance matrix over a DAG, we can do path analysis or structural equation modeling, forms of latent variable analysis. Even without any data collected at all, the structure of a DAG implies variable dependencies and independencies, which in turn have implications for what is and is not possible in the system from which the data were acquired, and thus can help guide critical thinking about problems.